All right, so the quiz tomorrow is section 6.3 and 6.4. So it's 6.3 and 6.4 quiz. All right, so today we're just going to review for it. So what I'm going to do, I already gave this quiz in my, what do you call it? Honors class, thank you. I already gave the quiz in the honors class. So what I'm going to do, and I've changed it up for you. I've put different numbers and stuff on there, but they're basically the same kind of problems, okay? So they'll look pretty much the same, but there'll be different numbers and different things like that, all right? So I'm just going to go 1 through 10 through the honors quiz, all right? And that should definitely help you with your quiz. So make sure you are taking notes, even though I'm recording it. I think it's, what was it squeaky? Why is that so squeaky? All right, so let's do number 1. It's a parallelogram. Actually, I think do I have a parallel? Yeah, I do. Good. Got a parallelogram up here. Just copy that one. Oops. And put it right there. All right. All right, this is number 1. Oops, there we go. Crazy marker. All right, this is number 1. So they tell you that this and this are parallel to each other. And what it says find the value of each variable that makes this quadrilateral a parallelogram. Or it says it ensures that each quadrilateral is a parallelogram. So right now, just looking at this, can I say that that's a parallelogram? Not right now, okay? Just because you have one pair of opposite sides parallel does not mean it's a parallelogram right now. Right, but they do tell you that they are parallel to each other, and they give you this. They give you this, and this side. They tell you these are the lengths of the sides. All right. To tell you the truth, I don't even think they need those arrows there. I don't for how they're asking the question. I don't even think you need the arrows. So I mean, it looks like a parallelogram, doesn't it? Right, but we don't know exactly that it's a parallelogram just yet. So what I want to do is I want to find out what should x equal and what should y equal in order to make this a parallelogram. So what must be true about the opposite sides of this thing if it was a parallelogram? That they would equal each other. Exactly right. Okay, so these two sides right here, if they're equal to each other, and if these two sides right here are equal to each other, okay, then it's a parallelogram. Everybody with me? So that's what I'm trying to do. It would be, if they said it was a parallelogram to begin with and then solve for x and y, you're basically doing the same exact work. You're doing the same exact math, okay? It's just they word the problem just a little bit differently. So what we're going to do is we're going to set, in order to make this a parallelogram, then these two would have to be equal to each other, and these two right here would have to be equal to each other. So let's set them equal to each other. So I'm going to go 7x minus 24 equals 3x. What? Yes. Weren't you already out? Oh, that was those two were out. Yes, that's fine. Let's see. Okay, so now what do? We solve for x. Let's do it quickly. Okay, we've done this a bunch of times before. So I'm going to subtract a 3x from both sides. I'm going to add a 24 to both sides. We'll do it in the same step. Okay? Everybody with me on that? Because I want the x's on the same side. All right, I put them on the left-hand side. So that cancels out. 7x minus 3x is 4x. This right here cancels out. That's 24. So what's x? X is 6, right? Because you divide both sides by 4. I just didn't show it. So x is 6. So that's one of the answers. But you got to solve for something else, too. What else do you have to solve for? Got to solve for y. So let's solve for y. So I'm going to go 7y equals 2y plus 5. Subtract, let's do this in our head. Subtract 2y from both sides. What do we get? 5y equals 5. Let's do this in our head. Let's get y by itself now. Divide both sides by 5. So y is 1. And there you go. So here, that's the answer to the question. Okay, x is 6 and y is 1. And if x was 6, that would mean these two would be equal to each other. If y was equal to 1, that means these two sides would be equal to each other. We had a theorem that says if both pairs of opposite sides are equal, then it's a parallelogram. So now we know for a fact, okay, if x was 6 and if y was 1, then this would be a parallelogram. Pretty basic, right? Yeah. Next one's kind of the same deal. Except, let's put it over here. I'll show my work over here. Except they're going to put some diagonals in here. All right, and then they're going to give you some lengths. They're going to say this length right here is, they put 1.5. It's kind of weird. 1.5a plus 2. All right, and then this one is 8. This one is b plus 7. B plus, oh, that's weird looking, b. Let's try this again. B plus 7. And the other one was 3b plus 1. 3b plus 1. We're basically doing the same thing, but we've got a little bit of a different situation here. We got diagonals. So the question is the exact same question as what was asked before. So what must A be equal to and what must B be equal to in order to make this thing a parallelogram, right? Well, what do we know? What do we know about the diagonals in a parallelogram? Remember, it's not specifically a rhombus, okay, but it is a parallelogram. What do the diagonals do? They bisect each other, exactly right. So they bisect each other, right? What does that mean, they bisect each other? Well, they split each other in what? In half, that's right, okay? So that means if this thing is split in half, right? See where they intersect each other right there? So if this is split in half, what must be true about this segment and this segment right here? They got to equal each other. If this one is split in half, what must be true about this segment and this segment? They must be equal to each other. Does that mean all 4 of them are the same? No. It just means these 2 are equal and these 2 right here are equal. Everybody see that? That's the geometry. All right? That's the only thing geometrically that we need to know about this thing. The rest is all just algebra. So if these 2 segments are equal to each other, what do? Set them equal to each other. Very good. So we set that equal to this. Now it's starting to look like what we did on the last problem, right? Let's do it. Subtract a b from both sides. That's 2b. Subtract a 1 from both sides. That's a 6. Divide both sides by 2. B is 3. You can almost do that in your sleep nowadays, right? You should be able to. Okay, so that's one of our answers. B is 3. Let's solve for a. So I've got 1.5a. It's kind of weird they put a 0.5 in there. I probably won't do that with your quiz, but on the honors quiz we did. All right, plus 2 equals what? 8, right? All right, let's do this. Let's solve for a. What are we going to get rid of first? The minus 2. So we subtract a 2 from both sides. And then we bring this down. We get a 1.5a. Remember, that canceled out. That equals what? 6. And what is that? 6 divided by 1.5. Is that 4? Okay, a is 4. All right. See what I did? Divided by 1.5. Yeah, I just didn't show it. And there you go. That's your answer right there. A is 4, B is 3. Now, if A was equal to 4, I could put it in here, right? And then I could see that this would be 1.5 times 4 is 6, plus 2 is 8. Yep, they're equal to each other. If I put a 3 in for this, 3 plus 7 is 10. Put a 3 in for this, 3 times 3 is 9 plus 1 is 10. This is 10, this is 10, so they are equal to each other. We good? All right. Let me do something here real quick, sorry.
Thank you. I was thinking myself.
Sorry for the delay. I just gotta take care of something. All right. Okay, here we go. Number 3 on the quiz. Oh, there goes my pen again. All right. Another one of these. There we go. Here's another one. Same exact kind of problem. Really, this is hard. This is no different than what we just did. I tell you what. Let's just skip that one. It's basically, well, no. Let's do it. Do you remember the one where we did, I think you guys can handle this. It's a little bit tougher. The geometry is exactly the same as what we just did on that last problem. The algebra is the thing that's a little bit tougher. Do you remember doing the substitution problem? They are? We've gone over it several times, though, haven't we?
Yeah, it's just
I think we should put it on there, don't you?
No. Anything with that, I'll bet.
That's right, Jason. Yeah, this is a challenger. That's a good way to describe it. Here we go. In order to be a parallelogram, what must be true about the diagonals? We just said it on the last problem. They got to bisect each other. So what are we going to do? We're going to set them equal to each other, right? So set 6a plus b equal to 25. And then set, what's that, 12a? It's my writing. I can't even read it. 12a minus b equals 20. What was the other one? Substitution and what? Elimination. We only did elimination one time. I think we did substitution 2 or 3 times. This one right here is made for elimination. So let me show you.
I do remember this.
No, it's only on only if it's a rhombus. Okay, we don't know this is a rhombus. So watch this. Everybody watch. I'm going to make this. It's actually called elimination, but it's actually elimination and substitution. What if I did this? What if I put it right underneath of there like this? See what I did? Now I did that for a reason. Now watch. Don't turn off just because this is a little bit harder. This is the time where you really need to pay special attention. So I put it underneath. You might remember this. We call this a simultaneous equation. And so what I can do, if I line them up, if I line the A's up and the B's up and then just the regular numbers up like this, what can I do with these? Yeah, but what am I doing when I cancel it out? What am I doing to this and this, this and this, this and this? I'm not just canceling it out. What do I do with that 6a and the 12a? Yeah, you add them together. That's right, okay? And when you take algebra, there's long explanation of why you can do this. I'm not going to go through that right now, but I'll just tell you right now that you can add these all together. So add the A's together, add the B's together, add the regular numbers together, and let's see what happens. Okay, so let's do that. It's not hard. What's 6a plus 12a? It will. And that's the whole reason why we're doing it. That's why it's called elimination. Okay? Did you hear what he said? He said, won't that cancel out the B's? Yeah, that's the whole idea. That's why we're doing this. That's why I'm not doing substitution. I looked at this and I saw a positive B and a minus B, a negative B. And I'm like, hey, wait a minute. I could do elimination on this. The B's will cancel out. It's going to make this a lot easier for me. I'm only going to put stuff on here that you can. Okay. In Algebra 1 and Algebra 2, I would give you more difficult things to do. But this is just perfectly made for you to do it this way, okay? It's a good question. It's just
Yes. If the food
What?
fits.
No, I didn't. I said it was a good question. I said it was a good question, but this is geometry. But
Bryce said it was a jump here.
well, that's what he said. I didn't say that.
I did not say this.
All right. So watch. Listen. Okay, nobody's going to listen to me. I'll just continue. Here we go. So if you add these up, you get 18a. If you add these up, they add up to 0. And you add these up, it adds up to what? 45. Okay? And So what do we do here? Divide by 18. That's not hard. Was it really hard to add those columns up? No, it was super easy, wasn't it? Okay, it's just knowing that you could do that. That's the hardest part about it. But now I showed you. So if you see this problem on the quiz, then you'll know what to do. It is. 12a minus b equals 20. Or 12a minus b right here. Yeah. Yeah, well, I'll show you what we're going to do. We're just going to put in a calculator and get a decimal. It comes out to a decimal. It doesn't come out perfectly even, but it does come out to 2.5 or 2.5. Okay? So that's what a is equal to. Now, how in the world do we find b? Plug it in. Plug it in where?
12A.
Yep, you can plug it into either one of these. It doesn't matter which one you plug it into. Okay, well, which one would you rather put it in? Would you rather put it into the first one, or would you rather put it in to the second one? Would you? Tell you the truth, I'd probably put it in the first one. I mean, you could. John, you're not wrong, okay? You're not wrong because you could put it into this one, but I think it's easier to put it in the first one, okay? So watch. I'm going to take that first equation, just rewrite it, but now I know what a is because I just found a. A is 2.5. I have like a third of you actually paying attention. It's the hardest problem we're going to do on the whole quiz, and I only got a third of you listening to me. Who cares? Just pay attention. Here we go. My word. Little babies in here. So 6 times a. What's a? It's 2.5, right? So I plug it in for this. Plus b. I don't know what b is. That's what I'm trying to find. Equals 25. What's 6 times 2.5? It's 25 quarters. What's that? $1.50. So that's what? Is that right? What is it? What's 6 times 2.5? I should be able to do that. What is it? 15. Okay. I don't know why I couldn't figure that out. Okay. And now we subtract 15 from both sides. And then b is 10. And there you go. That's your answer right there. It's really not that hard. Okay. Again, like I said earlier, the hardest thing was to understand that this is one of those elimination problems where you put one equation on top of the other. If you see that, if you see a plus b and a minus b, all right, on the quiz tomorrow, make sure you set it up like this. Then the rest of it's really not that hard at all. You just add the columns, solve for a, that was easy. Then you take that and you plug it into either one of these equations right here. It doesn't matter which one. Okay, I chose the first one, so you plug it in, work it out, all right? It's just basic math like we've been doing. And then there's your answer right there. All right, let's do another one. Okay. All right, so let's do number 4. Got a parallelogram again. Tell you what, let's angle it the other way. Is that right? So let's go 20. And let's go another 20. What? No. In the class, I'm collecting it. All right, here we go. Let's make this a little bit bigger because I'm going to write inside of this. And right now it's a little bit too small. All right, we got diagonals again. So there's one diagonal. There's another diagonal. All right, here we go. This time we're dealing with the angles, okay? Not the sides, not the lengths of the diagonals. We're actually talking angles here. So we need to know something about the angles when you have diagonals. We've got this. We've got this. And 2x plus 5 right here. All right, this is 3y right here. This is x. This is 2y. This is y plus 5. And this is 2x plus 5. And again, we don't know that it's a parallelogram right now, but we want to find what x and y should be equal to in order to make it a parallelogram. So what do we know about the diagonals in a parallelogram? Do we know that the two angles are equal to each other right here? Like, is x equal to 2y right here? We did that, but we didn't do it with a regular parallelogram. We did it when it was a... Anybody remember? We did it when it was a rhombus. We did it when it was a rhombus. When it was a rhombus, then those diagonals bisect the opposite angles, okay? But they don't necessarily do that when it's just a regular parallelogram, okay? But watch this. Everybody watching? Let's do this in a different color just so it stands out. So look, watch. This angle right here is equal to this angle right here. How do I know that? Alternate. Right, you got it. Okay, alternate interior angles. Okay, parallel lines, right? If it was a parallelogram, right? If these were parallel lines, and this and this would be equal to each other. You with me? All right, so now let's set them equal to each other. Well, we got another problem. I got two variables, I only got one equation, so I need another equation. Do you see another situation? Where is it? Yeah. So let's change colors there. So this right there, this 3y is equal to something in here. What's it equal to? It's equal to this 2x plus 5. That's right. Again, same reason, right? Alternate interior angles should be equal to each other. So let's write that down. So I've got 3y. Tell you what, let's do the x. That doesn't matter. We'll do the y first. 3y equals 2x plus 5. Now, this is not set up for you to do elimination. The other one was perfect for elimination. This one's not. But this one's perfectly set up to do substitution because I already know one of the letters, kind of, don't I? Which letter do I kind of know? I know x, right. Okay. Now, I don't know exactly what it is because I don't know what y is. But what I can do is take what x is equal to and put it where? Into the x in the other equation. That's my substitution. Everybody see that? That's the substitution. So let's do that. So what I'm going to do is rewrite this equation, but instead of 2x, I'm going to write 2 times y plus 5. Okay? We've done this. This is probably the 4th, 5th time we've done this in this class. So let's do it. What's this going to be? 3y equals 2 times x. What do I need here then? I need a parentheses, right? If I'm going to multiply it. And then, so all I did was rewrite this equation, but instead of putting an x there, I put in a y plus 5 in place of it, because that's what x is equal to. Remember, the x on this equation is the exact same x on this equation. The y on this one is the same as the y on this one. Now look what I can do. I can solve for y now, can't I? We might have done this exact problem in class, because I probably got this from a homework problem. You can look and see. What do I have to do with that 2? Distribute, very good. Distribute through this, so it's 2y plus 10 plus 5. Let's do this. Let's subtract a 2y from both sides. Everybody see that? So I've got y equals, let's add these together. 10 and 5 is 15, and that's it. So y is 15. It's not all of it, that's right. So I got to solve for x as well. But look, I already got x by itself up here, don't I? So just plug the 15 in for this y. So it's just 15 plus 5, so x is 20. That's all there is to it. Okay? This is a very, very common Algebra 1 topic. All right, so even though you might have not learned it last year, you've learned it in here. So whenever you take Algebra 2 next year and you do substitution and elimination, I want you to tell your teacher, oh yeah, we did that last year in geometry with Mr. Hamrick. He taught us that. Okay? You don't have to say that, but I just say that you learned it in my class. Okay. Here we go.
Handsome, outstanding.
All right.
Stop making me ill. He's just being silly. Don't pay him any mind. All right, here it is. They label these. Oh, there we go again. Stop touching that button on my pen. This is P, Q, R, S, and T. Now, they do tell you that this thing is a rectangle. So all the stuff that we just did was from section 6.3. This is from 6.4, okay? So they tell you it's a rectangle. So what do you know about this then, if they tell you it's a rectangle? Well, you know all 90 degrees. That's right. You got 4 90-degree angles, okay? So that's really important. That might help us a little bit. So here's the question. This is number 5 on the quiz. Remember, the numbers on the quiz you're going to take are different than the numbers here, but they're basically the same problems. They're just going to be different numbers. That's all, okay? I could possibly put the exact sum of the exact problems on the quiz. All right, so look for that as well. They ask you to find what QS is if PR is 12. All right, so let's take a look. Let's do this in a different color now. All right, find QS. Where's QS? QS, that's that big old long diagonal right there. Everybody see that? Yeah. But what do they tell you? They tell you that's supposed to be a P. That looks, why did I put RR? That was silly. How about PR? All right, and now let's go to a different color. All right, so PR is 12. So that means from here all the way to here is 12. So let's think about it. What's true about the diagonals of a rectangle? They do bisect each other because it's a parallelogram, but they do something more than that. Trevor, would you say? They're equal to each other. Exactly right. So when it's a rectangle, that's not true just about an ordinary parallelogram, but it is true about a rectangle. Everybody understand that? Okay, so if they tell you that if they tell you that PR is 12, what do you think QS is equal to? It's going to be 12 as well because they're both exactly the same. So if they tell you one, then the other one's going to be exactly the same. I got 1, 2, 3, 4, 5 heads down. Don't understand it because I'm giving away free stuff here. All right, I'm giving away free stuff. All right, so here we go. So QS would be what then? It would be 12 because PR is 12. All right, that was easy. But if you're not watching, then you're not gonna know how to do this. All right. Okay. All right. Here's another one. If QT is 5. Here we go. We got to find PR. But I thought we just knew PR. It's 12. What is a different problem? All right. So the stuff on this problem is not the same as number 6, okay? Everybody with me? We're starting from scratch, same picture, same letters, but different stuff. John, help me out.
Yeah, it's 5. PR.
Okay, so let's do QT. Let's write it in here first. So QT is what? 5. So this little bit is 5. We're trying to find PR, right? But very similar to the last problem, remember, the whole diagonal is equal to this whole diagonal. But this time they only tell you half of the diagonal. What's this little bit right here going to be? TS. That's going to be 5. Because remember, it's a parallelogram, right? As well as a rectangle. So the diagonals bisect each other. So this and this are equal. So QS is 10, all right? So what is PR? It's exactly the same thing, which is 10. Couldn't be easier, could it? Well, the first one, 5 was super easy. You didn't have to do any math on this. At least on this one, you had to add 5 and 5. But how hard was that? Not very hard.
Not hard at all.
Not at all. Okay, let's do another one. We're rolling right along here. We got another rectangle, but they're going to ask you some different information about it. This time they're going to talk about some angles in this rectangle. Okay? We already know something. We already know something about this angle, right? Did we really use that in the last problem, the 90 degrees? Not really, because we just found the lengths of the diagonals. But on this one, we're going to deal with the 90-degree angles, okay? So here we go. They named this angle 1. Instead of going PRQS and all that kind of stuff, they just named this angle 1. They named this one angle 3 right there. They said that this one right here is angle 2. And they tell you this one is 35 degrees. Okay, so here's what they ask for. They ask you to find angle 1, and they ask you to find angle 3. You're watching, right? So we got to find angle 1 right here. So how in the world do we do that? Well, let's start here. We know this is 35 degrees, right? So what could we find without it doing any math at all? I could tell you what angle 1 is without any math. Why is it 35 degrees?
Alternate interior.
You got it. That's what I wanted to hear. The alternate interior angles are equal, okay? Because if it's a rectangle, that means this and this are parallel, transversal, alternate interior angles are equal. If this is 35, angle 1 is 35. Piece of cake, right? Angle 3 is a little tougher. You got to do a little bit of math to find angle 3. So what did I say angle 1 was? 35. So let's put a 35 right there. Now, what about this angle right here? Why? I'll show you why. Okay, watch this. Remember the diagonals? They're exactly the same. Okay, so they're exactly the same. So, and they're both being bisected. So tell me something about all 4 of these like half diagonals. They're all equal to each other because I'm taking the same thing, right? Both of them are exactly the same, and I split them both in half. So would you agree they'd both be the same? Yeah. So now look at this triangle. See this triangle on the top where angle 3 is right here, and these 2 angles right there? Remember we had a theorem that said if you had 2 sides of a triangle that are equal to each other, that the opposite sides would be equal to each other as well. So if this is 35, then what's this? That's 35. But I'm trying to find angle 3. How does that help me find angle 3? That's it. Okay, so add them up, take them away from 180. Okay, so it's going to be 180 minus what? If I add 35 and 35. 70. And what's that? 110. And that's angle 3. Okay, so there's angle 3, there's angle 1, and that was number 7 and 8 on the quiz. 2 more. How you feeling so far on this?
Feel great. Besides, I don't like that.
What's that? Didn't have to find it. I only had to find 1 and 3. I don't know why. Yeah. Listen, Chance had a good point right here. I could, since I'm making a different quiz for you guys, but it's based on the same material, I could have asked angle 2. I didn't ask for that here, did I? But what if I asked for angle 2? What would angle 2 be equal to? Because I could ask that on the quiz. Is it 35?
Oh, no, subtract by 90.
That's it. Because watch. Remember, if this was 35, then what's this one right here? That one's 35. Does that mean angle 2 is 35? No, because they make up a right angle. So it would be 90 minus 35, which would be what? Is that 55? Yeah, so angle 2 would be 55 degrees. I didn't ask that on this particular quiz. I could ask it tomorrow. All right, one more. Well, 2 more, but 1 more picture. So let me draw a rhombus. So I start off with a square, and then I slant the thing by going down here, go to transform, go to shear, and that's good enough. That looks like a rhombus. All right, and let me mark some stuff. They put some diagonals in here. What do we know about the diagonals of a rhombus? Yeah, they bisect each other because it's a parallelogram, but specifically being a rhombus. They do something in a rhombus that they don't do for a regular parallelogram. Nathan? They're not parallel. Look, this diagonal and this diagonal are definitely not parallel to each other. They're what? Well, they're perpendicular to each other, okay? They are not equal to each other. Only in a rectangle are they equal to each other, okay? But they are what? Perpendicular. Now they also bisect each other because it's a parallelogram. All right, enough of that. That's angle 6. This is angle 5. This is angle 4. This is 60 right there. And that's it. Except they do this. E, F, G, and H. Now remember, this is a rhombus. They tell you. Okay, they tell you it's a rhombus. So tell me something about all 4 sides of this thing. They're equal. So that, and that are all equal to each other, right? Because it's a rhombus. By definition, those sides are equal to each other. Everybody with me? Mm-hmm. Number 9 says find angle EFG. Angle EFG. All right, where's EFG? Let's mark it in yellow. EFG, that's this big old angle right here. That's what we got to find. What do you think? Let's do this. Watch. What's something else that happens in this rhombus? They're perpendicular. Diagonals are perpendicular, but tell me something about this angle right here. See this angle right here? Where that dot is? See that angle right there where that other dot is? Tell me something about those 2 angles on a rhombus. Go ahead. Okay. They're equal. That's right. Okay, because they bisect opposite angles. Watch very carefully. Watch. Don't pack up. Okay? I hate that. Especially since I'm giving you answers to a quiz. Don't pack up. This is 90. This is 60. Look at this triangle right here. You see this triangle? Okay, not the whole big thing. I'm just talking about this little skinny one right there. What's that little angle right there going to be? That's 90. That's 60. That's 150. What's this going to be? That's going to be 30. Since the 2 angles are exactly the same, what's this little angle? That's 30. What's the whole big angle? That's 60. See what I just did? Okay, I looked at a triangle, 90 degrees. That's 60. That's 30. They're both 60. Last one. I'll just keep that in yellow. Angle 4. What's angle 4 going to equal?
Angle 4 is going to equal 30.
Yeah, and you can just look at it and see. Because watch. See this angle? See that angle right there? Look at that one and look at 4. For the 3rd time today, what's the relationship between this angle that's circled and this angle 4 right here? They're alternate interior angles, so they are equal to each other. So angle 4 is 30 degrees, okay? Put your homework up on the corner of the desk right here. So right here on the corner of the desk, put your homework. Make sure you label it properly. It's 6-4B. 6-4B. Make sure it says that and put it right there on the corner.